Now I'm going to discuss how we would look for a new law. In general, we look for a new law by the following process. First,
you think reality is just made of solid stuff. Tables, chairs, the floor beneath your feet, little hard billiard balls of matter bouncing around in empty space. You can touch them. You can measure them. You know exactly where they are. We all grow up with this assumption. It's classical mechanics. It's Newton's world. Newton told us that the universe is a giant clockwork machine. If you know where every part is and how fast it's moving, you can predict exactly what it will do next. You throw a rock, it follows a perfect parabola. You know where it started, you know where it will land. The world is solid, predictable, and definite. Fine. But what happens when you stop looking? What is matter actually doing when you aren't paying attention? Most people have never really thought about this. They just accept that the world stays exactly the same whether you look at it or not. The rock is still a rock in the dark. That's just common sense. But that's not an answer. That's just a bias and based on your size. When you really ask what matter is, when you dig down into the absolute smallest pieces of the universe, you discover something so strange, so fundamentally absurd, that it completely destroys the clockwork universe. You find out that the universe isn't made of solid things at all. It is woven out of probabilities and chance. Let me show you what I mean. Let's start with something simple, something everyone understands. Bullets. Imagine you have a machine gun. In front of you is a thick steel armor plate with 2 vertical slits cut into it. Behind that plate is a sandbox. You close your eyes and fire the machine gun wildly. What happens? The bullets that hit the armor bounce off. The bullets that happen to go straight through the first slit hit the sand and make a pile directly behind it. The bullets that go through the second slit make another pile, 2 slits. 2 distinct piles of bullets in the sand. Simple, predictable. Now let's look at water. Imagine a calm pool. You place a barrier in the water with those same 2 slits. You start pushing a board up and down in the water to make waves. The wave travels outward, hits the barrier, and squeezes through the 2 narrow slits. Now you have 2 new, smaller waves rippling out from those slits. As they travel, they crash into each other. Where the peak of one wave meets the peak of another, they combine to make a huge wave. But where a peak meets a trough, where the water is trying to go up and down at the exact same time, they cancel each other out to perfectly flat water. When these crashing, interfering waves hit the back wall of the pool, they don't make 2 marks. They create a beautiful repeating pattern across the whole wall. Strong wave, flat water, strong wave, flat water. This is called an interference pattern. So, we have the rules of the game. Solid particles like bullets make 2 piles. Waves like water make an interference pattern. 2 completely different, incompatible behaviors. Now, here is where the universe stops making sense. Let's shrink down. Instead of bullets or water, we are going to use electrons. Electrons are particles. They have mass. You can count them. They are the tiny, hard building blocks of matter. We set up an electron gun, a microscopic barrier with 2 tiny slits, and a sensitive detector screen on the back wall that flashes when an electron hits it. Since electrons are particles, like unimaginably tiny bullets, they should go through the slits and make 2 piles on the detector screen, right? You fire them, but you turn the gun down so low that it only fires 1 single electron at a time. Bap! A single flash on the screen. A single discrete dot. Bap! Another dot. Bap! Another. They are hitting one by one. They are undeniably acting like solid individual particles. But you leave the gun running. You go get a coffee, you come back hours later, and you step back to look at where all those thousands of individual dots landed. You don't see 2 piles, you see the repeating bands, you see the wave pattern. Wait, stop and really think about this. This is completely impossible. Electrons are hitting the screen as single dots, but collectively over time they are forming a wave pattern. How? To make an interference pattern, a wave has to go through both slits at the exact same time and crash into itself, but an electron is a single particle. It was fired completely alone. There were no other electrons for it to bump into. It must have gone through one slit or the other. How can a single solid particle interfere with itself? It's as if the single electron leaves the gun as a particle, dissolves into a phantom wave, goes through both slits simultaneously, explores every possible path it could possibly take, interferes with itself, and then magically collapses back into a solid particle exactly when it hits the screen. This should break your brain. You get frustrated. This violates everything you know about reality. You say, okay, this is nonsense. The electron has to go through one slit or the other. I'm going to outsmart it. You set up a tiny microscopic camera, a particle detector, right next to the slits. You want to watch the electron. You want to measure, definitively, which slit it actually goes through. You fire a single electron. Your detector flashes. Aha! I saw it! It went through the left slit! The electron hits the back wall. You fire another. Aha! Right slit! You watch them one by one. You are catching them in the act. They are behaving perfectly like little bullets, going through one hole or the other. But then you turn around to look at the final pattern on the back wall. The interference pattern is gone. It's just two distinct piles of dots. The exact moment you looked, the moment you forced the universe to tell you which path the electron took, it stopped acting like a wave. It collapsed back into being a normal, boring particle. By merely measuring it, by extracting information from the system, you completely change the physical nature of reality. The electron behaves like a wave of possibilities until you force it to choose a path, and only then does it become a solid thing. Now, you might ask, but why? Why is the universe set up this way? Why does reality care if a machine is looking at it? And here is the answer that is going to frustrate you. There isn't a deeper why. This isn't a glitch in our equipment. It's not a measurement error. It is a fundamental consequence of how reality is structured at its core. This realization didn't happen overnight. It was an avalanche of discovery, just like the one that started with Newton. It started with Max Planck realizing that energy isn't a smooth flow, but comes in little chunky packets or quanta. Then Einstein took that and proved that light itself comes in chunks, photons. Then a man named Louis de Broglie flipped it around. He said, if light, which we thought was a wave, can act like a particle, what if matter, which we think is a particle, can act like a wave? Then Schrödinger wrote the math for those waves, and finally Max Born figured out what those waves actually were. They weren't waves of water or waves of energy. They were waves of probability. Space and time at the smallest level are not a stage where solid objects move. They are a matrix where probabilities evolve. Before you measure it, a particle doesn't have a specific location. It exists as a blur of chance. The universe has a built-in limit to what can be defined at any given moment. It's not that we are simply ignorant of the electron's path. It's that the electron literally, physically, does not take a single path until an interaction forces it to. The uncertainty is woven into the fabric of reality itself. And here is the beautiful part. This isn't just theoretical philosophy to debate in a classroom. It is the absolute truth of nature, and we have tested it. In fact, you are relying on it right now. If electrons were just solid little billiard balls, they couldn't pass through solid walls. But because they are actually waves of probability, there is a tiny mathematical chance that an electron can simply tunnel through an impenetrable barrier and appear on the other side. We call it quantum tunneling. And once we understood that, we used it to invent the transistor. We used it to build microchips. The only reason your phone works, the only reason computers exist, is because we engineered machines that force electrons to behave as probability waves. Look even bigger. Look at the sun. The sun is a giant ball of hydrogen gas. For the sun to burn, hydrogen atoms have to smash together and fuse. But hydrogen atoms repel each other violently. At the temperature of the sun's core, they simply aren't moving fast enough to overcome that repulsion. According to classical physics, the sun shouldn't be able to shine. It should be dark. But it shines. Why? Because the hydrogen atoms are not solid balls. They are probability waves, and every so often, their waves overlap just enough that they tunnel through that impossible barrier and fuse. The light of the sun, the energy that powers all life on Earth, is a direct result of the universe being a blurry, uncertain game of chance. So let's bring this all together. Why does the double-slit experiment shatter our reality? Because it proves that the universe is not made of things, it is made of possibilities. Reality is structured in a way where nothing is absolute until it interacts. You cannot separate the observer from the observed. The act of measuring, the act of knowing, forces the universe to collapse from a cloud of maybe into a single point of definitely. And this avalanche of discovery, from Planck to Einstein to Schrödinger to the microchips in our pockets, shows us that the universe is infinitely weirder and infinitely more profound than our common sense could ever imagine. And the fact that we can understand this, that we as giant, clunky collections of atoms can peer down into the very basement of reality, figure out the rules of a game that defies all logic, and use it to build the modern world, that's the beauty of physics. Not comfort, not simplicity, truth.